So here's our sample problem in our geotechnical engineering. Refer to the soil profile shown in the figure below. Calculate the variation of stress, pressure, and effective pressure with depth. And B, if the water table rises to the top of the ground surface, what is the change in the effectiveness stress at the bottom of the clay and layer? How many meters must the ground water table rises to decrease the effective stress by 15 kilonewton meter squared at the bottom the clay layer? So here's our diagram. We have here 5 meters in the upper side and 4 meters in the lower side, and we have our E is equals to 0.52 for the sand, and GS is equals to 2.66. For the clay, we have E is equals to 1 and G is equals to 2.75. So in order for us to find the questions, we have here the equation for dry sand layer, or for Y dry sand is equals to GS multiplied by unit weight of water all over 1 plus E, which is 2.66 times 9.81 all over 1 plus 0.52 is equals to 17.168 kilonewton meter cube. For saturated, S is equals to 1 clay layer. Our formula we're gonna use is S is equals to GS multiplied by moisture content. So just basic algebra, we can get this. We can get the formula W is equals to SE all over GS. Substitute, so we can get 1 times 1 all over 2.75 because of 0.363. For Y saturation, 2.75 multiplied by 9.81 multiplied by 1 plus 0.363 all over 1 plus 1 is equals to 18.394 kilonewton meter cube. Now we have to calculate the variation of stress with depth at point A. So stress is equals to 0 and pressure is equals to 0 and effective stress is equals to 0. At point B, stress is equals to dry unit times height. So just substitute 17.168 multiplied by 5, then we can get 85.840 kilonewton meter squared. And for pressure is equals to 0, and for effective stress is equals to stress minus pressure is equals to 85.840 kilonewton meter squared. At point C, so sigma is equals to Y saturation height sub 1 is equals to dry unit with height sub 2. Just substitute the given values. 18.394 multiplied by 4 plus 17.168 multiplied by 5, we can get 159.416 kilonewton meter cube. For pressure is equals to unit weight of water multiplied by height sub 1. So 9.81 multiplied by 4 is equals to 39.240 kilonewton meter squared. For effective stress is equals to stress minus pressure is equals to 159.416 minus 39.240 is equals to 120.176 kilonewton meter squared. Now, for P, if water table rises the water table rises to the top of the ground surface, change in the effective stress at the bottom of clay. So sigma point C. So sigma is equals to stress minus pressure. So stress is equals to Y saturation of clay multiplied by height of 1 plus Y saturation sand multiplied by height of 2. So Y sat is equals to Y sat of saturation of sand is equals to GS plus E multiplied by YW or unit weight of water 1 plus E or over 1 plus E. Just substitute 2.66 plus 1 multiplied by 9.81 all over 1 plus 0.52. We can get Y saturation of sand is 20.524 kilonewton meter cube. For stress is 18.394 multiplied by 4 times 120.524 times 5 is equals to 176.196 kilonewton meter squared. For new stress is equals to Y saturation sand multiplied by height of 1 plus Y saturation of clay multiplied by height of 2 minus unit weight of water multiplied by height of 1 plus height of 2. So just substitute the given or the answers. 20.524 multiplied by 5 plus 18.394 multiplied by 4 minus 9.81 multiplied by 5 plus 4. So we can get 57.904 kilonewton meter squared. For delta stress is equals to stress old minus stress new. So substitute 120.176 kilonewton meter squared minus 87.906 kilonewton squared meter squared. We can get 32.27 kilonewton meter squared. Now for the C, find H when groundwater table used to decrease at effective stress by 15 kilonewton meter squared at the bottom of the clay layer. So delta stress is equals to 15 kilonewton meter squared. Now stress effective stress is equals to stress minus U. That's our equation 1. And for stress is equals to 5 minus H multiplied by dry unit weight of sand plus H plus time multiplied by Y saturation of sand plus height of 2 multiplied by Y saturation of clay. So just substitute, we can get the quantity 5 minus H multiplied by 17.168 kilonewton meter cube plus H quantity 20.524 kilonewton meter cube plus 73.576 kilonewton meter cube. That's our second equation. So our U is equals to Y W plus 4 plus H. Just substitute, U is equals to 9.81 multiplied by 4 plus H. So just equate the given equations, we can get the answer. H is equals to 2.324 meter cube. That's all. Thank you.